Welcome to Super Maths Help 24. We want to prove this important property of combinatorial coefficient. N combination R plus N combination R plus 1 is equal to N plus 1 combination R plus 1. This is like saying 5 combination 2 plus 5 combination 3 is equals to 6 combination 3. So let's get into the proof. Solution. I'm assuming you have a basic knowledge of combination, permutation and combination. So I won't be teaching everything. So now quickly, we know that N combination R plus N combination R plus 1 is the same thing as N factorial over N minus R factorial times R factorial. This one is also the same as N factorial over N minus R plus 1 factorial times R plus 1 factorial. Alright, let's try to relate what we have in the denominators and see if there's something we can factor out. Now, N minus R factorial is the same thing as N minus R into N minus R minus 1 factorial. So I'm relating, there's a relationship between this and this. If you open this bracket, you are going to get this. Also, there's a relationship between, look at this, R plus 1 factorial is the same thing as R plus 1 into R plus 1 minus 1 factorial. This will give you R plus 1 into R factorial. Once again, there's a relationship between this and this. Now, excuse me, introducing this relationship here so that we can factor something out. Our initial expression, N combination, N factorial over this. Now, I'm going to change this, okay, with what I have here. So this is going to be N minus R into N minus R minus 1 factorial and then R factorial, then plus this is N factorial all over. Now remember that this opening this bracket will be the same as this. So I'm just going to write this. This is N minus R minus 1 factorial, and then this can be rewritten in this form. I can rewrite it in this form. Is the same thing as R plus 1 into R factorial. Now, look at this. You notice that there are some things that we can factor out. I have N factorial, N minus R minus 1 factorial, N minus R minus 1 factorial, and I have R factorial. Then let's factor it out. If we factor it out, we have N factorial all over N minus R minus 1 factorial and then R factorial. And then I'll be left with here 1 over N minus R, then plus, I'll be left with 1 over R plus 1. Alright, we're making progress. So from here, I'm going to solve this fraction. And this will be N factorial all over, this is N minus R minus 1 factorial R factorial. The LCM of these two fractions will be N minus R into R plus 1. Cross multiply, you have R plus 1 plus N minus R. Now simplifying this, R and R will go, so what I'm going to have will just be this. So I'm left with N factorial all over that n minus r minus 1 factorial r factorial, and then my denominator will be n plus 1 all over, numerator is still n minus r, and r plus 1. Okay, now we have to establish some relationship. First of all, this and this can be combined. This and this can also be combined. So let me rewrite this as, okay, n plus 1 into n factorial. That's this and this. Remember, these are proved that there's a multiplication sign here. And then I'm bringing this and this together. N minus r into n minus r minus 1 factorial. And then I'm bringing this and this together. Into r plus 1 r factorial. Alright, so there's some things I need you to note. Now recall that n minus r factorial is the same thing as n minus r into n minus r minus 1 factorial. So the whole of this can be rewritten as n minus r factorial. What of this? R plus 1 factorial can also be rewritten as r plus 1 into r plus 1 minus 1 factorial. This is the same thing as r plus 1 into r factorial. That's what we have here. And also the numerator, n plus 1 factorial, can be written as n plus 1 into n plus 1 minus 1 factorial. This will give me n plus 1 into n factorial. Now, replacing this, the numerator with this, n plus 1 factorial all over, and then this, I'll replace it with n minus r factorial. This is n minus r factorial. That's the whole of this. Now this will be replaced with r plus 1 factorial, and then this is the same thing as n plus 1 combination n minus r, r plus 1. Now notice that the formula for combination, this will be n plus 1 factorial into this minus this, and notice that n plus 1 minus r plus 1 will give me n minus r. So this minus this will give me this factorial and then this factorial. This is an important rule, an important property of combinatorial coefficient that we should know. We'll have two others that I'm still going to prove. Thanks for being a part of this video. Hit the subscription button so that, or follow our page so that you will always get these contents when they are made. Thank you.